Hello, welcome to another episode in the Monogame tutorial series. Today we're going to be covering tilemaps. So if you ask 10 different developers how they would draw a tilemap, they would probably give you 10 different answers. There is no de facto way to do this. Today I'm going to be showing you a pretty popular and very fast and very memory efficient approach to this. So what is that approach? Well, first, we're going to be loading our data from a CSV file. Now, if you've never worked with one, this is what it could look like. It's basically just numbers separated by commas. This is a very popular way to store tilemap data. If you've ever worked with something like tiles, this is one of the options for exporting your data. Now, what does this actually mean? So these numbers represent different tiles. For in my case, the 1 represents grass, 2 represents dirt, and 0 represents air. The actual location of them in the CSV file dictates the location of them in the tilemap. So for example, this one right here is at position 1, 1 because we go over 1 and down 1. So how are we going to parse this data to use it inside of our game? Well, I've made this little graphic to hopefully help. We're going to be storing them in a dictionary. And if you've never worked with one before, it's basically just a list of key value pairs. The keys are going to be the position of the tile, so the X and the Y coordinate, and then the values are going to be a texture key, and the texture key is going to map to a source rectangle. If you've never worked with a texture atlas before, that's what we're going to be doing today. I think I have a tutorial on it in the past as well. Basically, a texture atlas is just a big texture with all your textures on it, and you just say, hey, I want to draw wood, so let's crop out this little 8x8 chunk of it and draw only that part. And so that's what's going to be on this side of our texture store, which is what I'm calling it. Okay, now I'm going to answer one question before we get a lot of comments. Why not just store a list of sprites? Why not just load the data into a list of sprites with their positions and their textures and draw that? Two reasons. One, it's not very memory efficient. So for a small game, like a small little farming sim with like a 10x10 grid of stuff, totally fine, go for it. If it's easier for you, do that. But for a larger game, like let's say Terraria or some larger game with a lot of tiles, you probably don't want to store a sprite for every single tile. The reason is that that's a lot of memory. If you're storing a vector 2 for each of them, that's 64 bits, and then you're storing your textures for each of them, which is the width times the height times, I think it's like 32 bits, I think. So that's quite a bit of data. And collisions and anything to do with that sort of stuff like collisions, checking collisions, and interactions and stuff is harder. Dictionaries are really cool because looking up stuff in a dictionary is linear time. You just hash the key and get the value. It's pretty nice stuff. So that's my justification. Let's get coding. First thing we want to do is we want to go to our game1.cs and represent our data structures in memory. So I'm going to create some sort of variable here, and then in the angle brackets I represent the key value pair. For us it's going to be the vector 2, and for the value it's going to be an integer. And I'm just going to call this my tilemap. And that's it. Now we want to make our texture store, so we want to make a private, I'm just going to make mine a list of rectangles and call it my texture store. Okay, so now we have to have a way to load in this tilemap. I'm going to create a little method here for doing that, and I'm just going to copy this data type, make a private method, and just call it load map. Why not? I'm going to say load map. Give it the file path, and write out this logic. So now what we want to do is we want to return a dictionary with this key value pair. So first thing I'm going to do is I'm going to declare our result. Result equals a new dictionary. And we're going to be using the stream reader for this because it's pretty easy to work with. I'm going to use a stream reader, which comes with C#. Just call it reader equals new, takes in a file path. So give it that file path. Now what we need to do is we need to define a empty string to hold our lines. And we need to loop over all the lines. So while line equals reader.readLine does not equal null, what this line is saying is it's looping until the line is null. And once the line is null, that means we've reached the end of the file. Okay, so now we're just going to basically grab the contents, which is inside of our line now. We'll say string items equals line.split, and we want to split at every instance of comma, which is our delimiter. This will give us an array of strings. But we're not done yet. We have to parse these into integers. And so what we do is we say for, and I'm going to use the normal for loop here because the position matters. So for x equals 0, x is less than items.length, x plus plus. And then we'll basically just say if int.tryParse, and then we need to parse the items at x and out an int value here. And this will just basically say, if we successfully parse the value into an integer, then we want to actually add it to our results. Otherwise, we'll just not care. It's okay. Now, of course, we also need access to our y value. So I'm going to create a counter for our y value. So int y equals 0. And every single loop inside of our while loop, we will increment y. One last check here. We just say if value is greater than 0, so it's not error, because why would we store error? There's no real point, for me at least. Then we'll say results at, and then we just specify the key here, which is a new vector 2, and then we just plug in our x and y, and then we say the value is just the value. There we go. One last step, just return the results. And that is your entire load map implementation. We can now go up to our constructor and say tilemap equals load map. We have to know where our file path is. And in a typical .NET application, if we go to bin, debug, and net 6.0, or release if you're building for release, it is 3 folders in for the executable. That's where our starting directory is. Mine is in data at the root of our project. So we need to go back 3 folders, then into data, then specify the file. So back 3 folders, into data, then specify the map.csv. That will load in our map perfectly fine. Now we need to define our texture store. So I'm just going to say texture store equals a new list. And inside of this, I'm just going to create some rectangles. So new rectangle. And this is just going to be for the grass. My grass is at the very top left. So the X and the Y are just 0, 0. And then the width of the width and height of my textures is just 8 by 8. So 8 by 8. Then for the dirt, we are going to do 8 down from that because it's the one below. So new rectangle here, 0, 8 for the Y, and then 8 and 8 again. And there you go. And the actual value that we get from the CSV is just going to be mapped to here. Of course, indexing starts at 0, so we're going to actually be subtracting 1 for ours. Okay, one last thing to do is just to draw everything. So what we'll do is we'll just loop over them inside of the draw. So we'll do for each var item in tilemap. And this item, if you hover over it, the value is key value pair with vector 2 and int. Okay, so what we'll do here is we'll define our destination rectangle, which again is defined by the position inside of our CSV. So rectangle dest equals a new instance of a rectangle. For the x value, what we need to do is you need to first cast it to an int, and then get the item dot first, dot key dot x, and then multiply that by 8, and then do the same thing for the y. And then I'm going to be doing, actually not 8, I'm going to be doing 64 so it's a little easier to see on the screen. And then just do 64 and 64 for the width and height. Then for the source rectangle, we just grab it from the texture store. So we'll do rectangle source equals texture store at, and then we need to do item dot value. And again, -1 because indexing source is 0. Then we just make our draw call, and life is good. So we need the actual texture, and I totally forgot to load it in. So let's go ahead and do that. So private texture 2, bit of review from the old videos. So texture atlas here. Load it in the load content again. So we'll do texture atlas equals content.load, angle brackets, texture 2D, and then specify the name, which is just atlas. And then over here, we specify texture atlas for our texture, destination for our destination rectangle, source for our source rectangle, and color for our color rectangle, and also .draw. Thank you. Okay, that will all work, and I will explain everything slower at the end. Hit F5 to run. Let's see this tilemap on screen. There you go. We have our tilemap all, it's nice little mountain. Can you tell that I made it in a text editor? Okay, so let's go over this line by line. So we're looping over every item inside of our tilemap. So we are basically grabbing every single key value pair. First, or key here is grabbing the key, which is the actual position. And we're basically looping over these X and Y positions, multiplying them by the tile size so that we're shifting everything over by its tile size. And then we are saying that it should be this big on the screen. So I want my tiles to be 64 by 64. So I'm specifying 64 by 64 here. If we were to, let's say, double the size that we are doing for this multiplication here and run it, what you'll notice is that there will be a tile gap between each of them. That's just some cool little simple math for you. Now, for the source is just right here. We're just defining it right here. So we're just grabbing it based on the index inside of our list. And then the draw call is just a standard sprite batch draw call. Very cool stuff. If you were to provide an offset or like a camera offset, you would do it inside of your destination. So I can do like -100 here, and you will see that they should be up and to the left a bit. Yeah, right there. So that's basically it. There is stuff like collisions with tile maps and stuff like that. That's a little bit interesting, a little bit out of scope for this one video. But if you want a video on tile map collisions, let me know and I will show you how to do that with this implementation. Anyways, that's the entire video, so I hope you enjoyed. I hope you learned something new. If you have any questions, make sure to join my Discord. I will be answering questions there, and consider supporting me on Patreon so I can continue making videos like this. Thank you very much for watching. Have a good day. See ya.